if you look at a data lake, first of all, a data warehouse is a Bill Inmond's definition of data warehouse is a subject-oriented, integrated, time-variant, and non-volatile. So it is a domain-specific integrated data. You take the different domains and integrate the data, and you hold the history of the data. And once it gets into the data warehouse, it's not going to change, right? So that is how the data warehousing concept has been there for decades. And Ralph Kimball has a simple definition, which again the same thing, but it means that it's a copy of transactional data specifically structured for query and analysis. So it is structured data with a well-defined structures and the data layout that you can easily create query and do the analysis, right? So, and James Dixon from Pentaho, I'm quoting him, he provided a definition of a data lake. So if a data warehouse is a store of bottled water, cleared, packaged, and structured, the data lake is a large body of water in natural state streaming from multiple sources for the user to dive in. So the data lake, from the concept of data warehouse, is very open, as you can see. And in addition to that, comparison of a lake versus a bottled water, if you look at the data lake, there are a few aspects. How do we compare it with the data warehouses? One is the data storage. Is that data lake can hold any kind of data, right? So if you are looking at a data warehouse, there are a lot of analysis goes on what kind of data needs to go into data warehouse, what needs to be excluded. For the data lake, you have everything going in raw data. And the data lakes are built on commodity hardware that is cost effective and cheap. And the data stores or can expand horizontally. So we had decades before SMP architecture is very famous. Then Teradata introduced MPP, and then Netezza or IBM adopted that. And nowadays, in the same model but with a different design, we have Hadoop as a big data architecture. So, and the data storage and data types. So with the, as you see before, the data warehouse only has structured data. So with the data lake, you can have both structured and unstructured data, and schemaless, which means that schema on read or schema on write versus. When we build the data warehouse, you need to know how do we store the data. With the data lake, the schema is open. Like, you schema on read, you load the data and then provide the schema later. So, and the user types, with the data warehouse, you have users mainly as operational users and business users, and some analysts doing some analysis, analytic work. But with the data lake, in addition to those, you support data scientists for doing deep analytics. So if you in the data warehouse, if you're doing a descriptive analytics, which is like why it happened, I'm sorry, it's what happened, right? So what happened with this? If we go with the data lake, it is more of a predictive analytics. It's like what can happen, and have diagnostic analytics of why it happened, and then prescriptive analytics of recommendations, right? So you can have much deeper analytics with the data lake with the raw data. And agility, when you store the raw data, you can quickly build different paths of data processing and data analytics needs for data analytics needs. Whereas in data warehouse, you have to go through the life cycle model for whether it's data life cycle, data modeling life cycle, or for any small, even for a small change, and it takes time to make the change. The agility is some advantage. So so data lake can be used for many purposes, and some of the uses I mentioned here is data staging, and as a raw data repository. And if you use it just for raw data repository, data staging, data lakes don't have much value, because you are just having it as a in front of the data warehouse just to feed the data. But the data warehouse, data lakes can do data transformation, data discovery, and data analytics, and as mentioned, they do deep data science.